All right, so let's finish up functions from what we started on Friday. What else? Today's a lot more algebra, so that'll be a good review because we're going to see algebra all the time. All right, let's go right to examples because we now know what a function is. We kind of talked about that. We looked at it graphically. We can talk about it as we go through it today. The directions are evaluate the difference quotient. It's a little blurry. All right, what's a difference quotient? Difference means we're going to see what operation's different. Subtraction. Quotient is division. Okay, so we're going to see our fractions again. All right, and so we're going to evaluate. We're going to see difference in quotients. So let's take a look at this problem. They're going to tell us f of x. So those are the directions. This is kind of like example 1. F of x is 3 plus 2x minus x squared. And here's our difference quotient that they want us to look at. F of 4 plus h minus, there's our difference, f of 5 divided by, that's our quotient, divided by h. So we just have to evaluate that. So this is kind of the end of Friday. We have to, in place of, we're going to rewrite the f function. Every place there's an h, or every place there's an x, we're going to write the quantity 4 plus h. So we're going to rewrite, this says rewrite the f function. So 3 plus 2. Now what am I going to write in place of x? 4 plus h. So in parentheses, 4 plus h. Minus, I'm not even to here yet. I'm still writing f. Minus, now I'm supposed to write x. What am I going to write in place of x? 4 plus h, and I still have to square it. So far I've only done this part. Then comes minus. Now it's this. This minus is this minus. Now I go back to the f function again. This time, every place there's an x, I'm going to plug in a 5. Be careful though, this minus goes to everything after it. So on my own, I have to put in parentheses. Because I want to subtract this entire function. So minus parenthesis, 3 plus 2. What are we going to put in place of x? 5. Minus, in place of x, 5, and then square it. So make sure that you do the entire function. A lot of people will do 3 plus 2 and put in there, and then they kind of stop. So make sure that you follow it all the way through. Now, what is it over? Bad fraction mark, but it's over just h. Notice it's not telling us to go to the f function at all. So that's at least a plus. The bottom is just simply h. So if it doesn't say go to the f function, then you're just copying it down. Now we just got to clean up the top. Now it's algebra. So we're going to distribute the 2. So we still have the 3 plus. Let's distribute the 2. So 8 plus 2h. This next part is going to take a lot of work. Okay. So the first thing I'm going to do is minus, that's this guy, and then I'm going to write this out twice. Not only do I have to FOIL, but I have to distribute that negative as well. So normally when you distribute, the parentheses go away. So we're going to do first, it's going to be 16, outer is going to give us 4h, inner gives us 4h, and last gives us h squared. But I still have parentheses around that because of the minus sign. So you still have parentheses around that because of that minus sign. So let's collect like terms. We can put these together. 16 plus 8h plus h squared. But it's still parentheses because you still have that minus. All right, so let's rewrite what we have. We've got the 3. We've got the 8. We've got the 2h. Keeping it on, we'll move it up in just a minute. Distribute that negative. So it's actually going to be negative 16, negative 8h, and negative h squared. Okay, now that's just that first half. We still have to do all of this. This is not bad, right? Because it's all numbers. So let's just don't lose this negative sign. So I'm going to bring that bring that all the way down. I probably should have waited. Let's actually, well, that's parentheses because I still have to evaluate this. All right, so 3, we can do it here. 3 plus 5 times 2 is 10, minus 25. That squared, that negative is not part of the squared, so it just comes down. That gives us what, 13 minus 25. So that we could write it, 13 minus 25. So that gives us negative 12. Slide it up. Okay, don't forget there's a denominator all over h. But now I think we're in good shape. What's the only thing we could do here? I collect like terms, but we could change these two negatives into positive, plus 12. All right, so we've got 3, 8, negative 16, and then positive 12. Those we can all collect like terms. So 11 minus 16 plus 12 should take us to 7. We could do that last if we wanted to too. I'll put it back because it's the constant. We usually put the constant. Yeah.
How did you turn the 12 into a positive?
So okay, so this in here, good question. Good. She said, maybe I should repeat it too so everyone could hear. She said, how did this turn into a positive 12? This in here is a negative, maybe I'll write it right here. This is a negative 12. Okay, 13 minus 25. If you do this 3, this is a positive 10. This is going to be a negative 25 though, because you 5 squared and bring down the negative. But I have this negative sign in front. Does that help? So remember, 2 negatives become a positive. Okay, 2 negatives become a positive. Question? So yeah, so you should have had a double negative there. Underneath this in the parentheses a negative 12, and then you do have that minus sign out in front. Okay, we have this h squared. This is our only guy. Maybe we should put that first, negative h squared. Okay. And then what else do we have? 2h and negative 8h. So negative 6h. And then all over. And that's good. I think we could do some factoring here, but if we factor, we're not going to be able to cancel, so it doesn't really hold a purpose. Can I cancel these h's? Nope. Bottom's good to go. Top, it's attached to subtraction. Okay. Same thing here. I can't cancel an h here because this guy's attached to subtraction. Now, this has an h. This has an h. If this had an h, then we could cancel, but we'd also have to cancel on the bottom. Everything has to have an h, all or nothing. Question?
I was wondering, because sometimes you can, I guess, parentheses, if that's 6, 8, 2 parentheses, what, divide it by 6?
Say that again. Could we divide by 6?
Well, I mean, like, sometimes we do that, but I guess that's dependent on parentheses, right?
Yes, that's probably true. Yeah. we could, maybe if we were gonna factor out a 6, then we could do something with division. But we're not, we're just gonna leave it just like that. All right, should we try another one? Question. Each was a little bit different, so this one will be a little bit different, but all right, let's try 2. Same thing, it's gonna be a difference quotient. I have to slide it down. Yeah, well, I don't know why it seems like extra blurry. Okay, should I? Okay, it's f of x is going to be 2 over x. My difference quotient is going to be f of h minus f of t all over h minus t. So we just got to be careful because we have a fraction, our difference quotient, right, is our fraction. And then we got a fraction here. Our f function is a fraction. Who loves fractions? Here we go. All right, so let's just take it one step at a time. What is f of h telling us? Rewrite the f function, and in place of x, we're going to write h. So right here is going to go 2 over h. We rewrote the f function. In place of x, we put an h. Okay, can you do it for the second one? Minus, this time it says, hey, go back to that f function, rewrite it. In place of x, write t. So 2 minus, this minus is coming right from here. And then 2 over t. Now we still have the denominator. What's the denominator? It doesn't tell us to go to the h, or it doesn't tell us to go to the f function. So we get to keep it, h minus t. So we're going to ignore that denominator. What do we have to do first? Here we have to get a common denominator in the numerator. So between h and t, it's going to be ht. You need one of each. So here we're going to put a t on the top and bottom. Here we're going to put an h on the top and bottom. So now we have, and we've got room, let's do this. We've got, so this top is going to be 2t over th minus 2h over th. And we still have the bottom, h minus t. All right, this looks messier. Should we go back to the original? No, we like that because we have a common denominator. So you subtract the numerator and the denominator stays. So the top is going to be 2t minus 2h. And I only have to write the bottom once, th. Now I still have divided by h minus t. How are we doing? Instead of, okay, so we're going to put this, let's make this a fraction too. Because instead of dividing, what are we going to do instead of dividing? Multiply by the reciprocal. So 1 over h minus t. And then this guy's gone. This took its place. Okay, I think, let's see, let's sneak it on here because there's one more step. So we've got 2t minus 2h, and that's it, because now the top is times 1. And on the bottom, we have th times h minus t. So I just put the top, for multiplication, it's nice. You just go straight across on the top, straight across on the bottom. Any ideas? We can make it look a little bit better, a little bit smaller. Remember, now we're just simplifying. Simplify means make small. Any ideas? Not a bad idea, and it's definitely an option. But as soon as we distribute, then that takes away multiplication and that takes away any option to cancel. So we're going to do the exact opposite. Instead of distributing on the bottom, let's factor the top. What can we take out of the top? A 2. So let's take a 2 out. So we've got 2 times, so the 2 goes away. Now we just have t. The 2 goes away here, minus h. Now we can cancel stuff if we want, because now we've got multiplication on the top, multiplication on the bottom. Who remembers how do we cancel a t minus h with an h minus t? It cancels with -1. You could factor out the -1 too if you wanted. I don't know if that messes people up or not. The reason we can cancel is because of factoring. Yeah, but we could otherwise, if it's just subtraction in the other order, we can just cancel and make this negative. If it's subtraction in the opposite order, you can cancel it with a -1. And so now we have -2 over TH. Definitely a lot smaller. So that's definitely simplified. That's definitely the best answer. Yeah.
Because you took out -1, because technically -2 over h times -1, you have to change any signs, or does it stay the same?
So I can just cancel this and put the negative out in front if I want. Here, let's do this though. Let's talk about why. Let's slide this up. So let's go back to this. Oh, no, not that. 2, we had this, right? So if I take out a negative here, it's going to be -2. I'm going to take the negative out. The t then becomes negative and the h becomes positive. If I actually take the time to show the factoring, if I show the factoring, I'll take that negative out and that changes both signs. This is the same, right? This I'm just going to rewrite. So -2, I'm just going to take the time to write the h first and then the t. Oh, sorry, hang on guys, this is supposed to be minus. That's just a copy. Yeah. H minus. All right. And so then those cancel, and I still have my -2th. Right? So if you want to actually take the time to factor, that's okay. Then both of these signs have to change. Does that help a little? Is that,
I didn't see that you wrote the negative sign, so I was thinking it was already -2.
no, okay. That's an awesome point too. Okay, very good point. She said, yeah, make sure that when I cross this out, this negative got written down as well. Yeah, that's a very good point. Very good. Okay, good. That's good. We can do it. And that was good to see anyway. See why we can cross this out. Yeah, this ties with this for sure. Good. Good. All right, let's do one more of these and we'll change gears a little. Okay, so 3, let's see. Okay, there we go. All right, so this f of x is x plus 8 over x plus 2. And then our difference quotient. Come on, it was worth just coming to hear that, right? Difference quotient, we sound impressive anyway. F of x minus f of 1 over x minus 1. All right, so we kind of got the beginning down. I think we're pretty good. Just take the time, make sure you get everything written down. So we're going to write the entire f function. Oh, look at this one. In place of x, what are we going to put? X. We just literally, it's saying, hey, copy it. Look at what it says. It says write f of x. Okay, so f of x is this guy. X plus 8 over x plus 2. Minus, always be careful of minus. We're going to do a difference quotient. This is going to come up in the first thing in chapter 2. We're going to see different quotient. So it's good to practice this now because it's going to come up in a different situation. Okay, now this says every place there's an X, we're going to write the number 1. We're actually going to get to put in a number. Because of that minus, make sure you have parentheses. 1 plus 8 over 1 plus 2. And don't forget your bottom denominator, your X minus 1. Sometimes I leave that out, just less to write. Just don't forget to bring it back in. Okay, so this there isn't much I can do with, at least not yet. So X plus 8 over X plus 2 minus, and then this is going to be a number though. What is it going to be? It's going to be 3, 9 divided by 3, 9 over 3. So it's going to be 3, maybe I'll keep it a fraction, 3 over 1. Because what do I still have to get? Common denominator. At least it has a bottom of 1, so I don't even have to, I mean, technically, I guess some of you might like to multiply top and bottom by 1 here, but you don't need to do that at all. So this side, though, needs an X plus 2. I have to match it on the top. Now, I'm not going to distribute a 3. What am I going to distribute? What should I take with it? -3. Get that done. The negative has to go anyways, so it might be worth, some of you might take the time to write plus a negative, and that's okay. Distribute that -3, get rid of that, go have it go, because it has to go to everything anyways. So don't lose that negative. All right, so now we've got X plus 8, -3X, -6. Are we okay only writing the bottom once? Since I had that common denominator, I only have to write it one time. And then I still have it all over X minus 1. Okay, we've got maybe 3 things left. What do we want to do next? Probably, this looks kind of long. What could we do up here? Collect like terms. Let's go ahead and do X minus 3X. So that'll give us -2X. 8 minus 6. That'll give us 2. Don't forget it's over X plus 2 and then over X minus 1. Make this guy a fraction. And then instead of dividing, multiply by the reciprocal. Instead of dividing, multiply by the reciprocal. Make that guy a fraction. Since everything else is a fraction, might as well be one too. Instead of dividing, multiply by the reciprocal. Now, we're almost done, but it doesn't look like anything cancels. Any idea? So we go straight across. So we have -2X plus 2. That's the only thing on the top. And the bottom, we've got this quantity X plus 2 times X minus 1. Any ideas? We're not going to FOIL the bottom. What are we going to do instead? Factor that top. Yep, factor the top, because factoring changes it to multiplication, which allows us to cancel. Okay. I'm not going to take out a 2. I might as well take out what? -2. Yeah, we usually like to make that first one positive. So if for some reason we want to go back, we could always distribute it back through, but usually we like that first one positive. So let's take out a -2. Then we're left with a positive X. What's going to be the next thing I write down? If I take out a -2, -1. Remember, if you get stuck, divide, and I know it's kind of messy, but divide both by -2. And that'll remind you that you've got a -1 there. And then bring in your bottom, look at that, X plus 2, X minus 1. Now remember, they won't all cancel. I think the first one, nothing really canceled. But these other ones, now the x minus 1s cancel perfectly. And we've got -2 over x plus 2. All right, so like I said, that's going to come up in the, I think it's section 2.1. So we're going to be doing something totally different, and we're going to have to do all that simplifying on top. Okay, so it'll help to see it now, kind of review it. We'll be ready to go. All right, another important thing, and so it came up again, it was in the review, is domain. So let's take a look. They also have us graph a little. It's not like in the review though. I think the graph, you just choose which graph it is. So we'll kind of talk about how that comes up. But let's change gears. We're going to find the domain. So find the domain. So, and if you can remember this from the review, then you're going to be fine. F of x, is this, what is this example 4? Yep. Find the domain, sometimes they say state the domain. That's probably more official. All right, f of x, so they just use function notation, x plus 3 over x squared minus 25. What do we have to worry about? The domain says, what can I plug in and get an answer out? I plug in a 7, I'm fine. I plug in a 10, I'm fine. Where do we have problems? Where am I going to actually put a number in and nothing comes out? When the denominator is 0. Okay, 7 over 0, or I think this one would be 8 over 0. 8 over 0, as soon as there's a 0 on the bottom, it's undefined. What's 0 over 8? That's fine. That's 0. There's no problem. If you get messed up, put it into your calculator. So literally do 0 divided by 8. It'll give you 0. If you do 8 divided by 0, it'll say error, undefined. Okay? And so that's what we want to tell people. This number is going to give you an error when you plug it in. So all you care about is the bottom, and you have to factor that. How do we factor that? That's our difference of squares, x plus 5 and x minus 5. What times itself gives you x squared? What times itself gives you 25? It's a difference of squares, so that's the only one you can factor. If it was a sum, we wouldn't care. Yeah, if it was a sum, it would actually, we wouldn't have to worry about the domain. Everything would be okay. All right, so now we just have to say the domain is everything except -5 and +5. So now the shortcut way is x cannot be -5 and +5. But our interval notation, how do we do interval notation? -infinity all the way up to -5. You do not want to include -5 because that's our problem. And then we want to go right after -5 to 5. Again, all parentheses. Brackets include the number, and that's the only number we want to toss, -5 and 5, and then 5 to infinity. So everything's okay. This is a fancy way of saying everything's okay except -5 and 5. Everything. Fraction, decimal, 0's okay. We literally can't have 5 and -5 because it makes the bottom 0. Okay. How about 5? It's almost identical. F of x equals 4x to the 3rd minus 7 over x squared minus 3x plus 2. When we have a fraction and we're talking about domain, we want to make sure we tell people what makes the bottom 0. Easiest way to see that is to factor. So what multiplies to 2 but adds to be -3? negative 2 and negative 1, two negatives, right? So x minus 2 and x minus 1. And so what's the only two numbers we have to toss out? 1 and 2. Is there numbers between 1 and 2? Better say yes, right? There's all those crazy decimals and fractions, but those are all okay. We just want to literally throw out 1 and 2. Try, I know I put my parentheses like this, but try to go low to high. So make sure that you toss 1 first and then 2. So domain is negative infinity up until 1. And then between 1 and 2 is okay. And then 2 to infinity. Do we see where 1 and 2 is coming from? Okay, how about, oh, let's do 6. F of x is x squared plus 4x plus 3. What is that? That's a polynomial that we want to hug. It's a regular old polynomial. It doesn't have a fraction. There's no radicals or anything like that. What's the domain? Everything's good. Main thing is fractions or radicals. Fractions or radicals. That's usually what kind of is going to cause us trouble in this class. So even stuff like sine and cosine, even trig is, everything's okay. Tangent's a little bit different, but so a polynomial, we like regular polynomials. Domain is negative infinity to infinity. Okay, so take advantage of them. Regular polynomials, like I said, at the end of Calc 2, we change things that we don't like into polynomials. We're going to actually change sine of x into a polynomial because they're easy to work with. All right, how about, let's take a look at this one. Still find the domain. Where's my architect majors who are glad that they don't have to do Calc 2? All right, were we on 7? Yeah. 7. It's a process too, people. All right, how about this? Let's change it up. Let's just do g of x. Remember, we can name it to whatever. Let's do a square root. So we said our hiccups are fractions and square roots. This we pretty much did. Like I said, it's fairly important. So I thought we would do it again, especially since it was in section 1.1. This is the one they have you graph. Does anyone know what a square root looks like? And again, you just have to pick the graph. So you can play around if you like. But does anyone know what a square root looks like? It's a parabola on its side. Now don't draw this. Don't draw this. It is a parabola on its side. Does anyone know what the problem is with this? It comes from Friday's lesson. It's not a function. Exactly, it has 2 y values. That's a huge problem. In fact, technically, I can't use this notation because this is technically function notation. So what we do is we just don't do the negative. We just say if it's like this, then it's like this guy. Okay. Technically, I only have to do plus and minus if I draw in the square root. And so we just assume that it's positive. We assume that if the problem has a square root in it, that we're just going to do the positive. Remember when we drew the square root, we put a plus and minus out there? If it's not written plus or minus, then we just assume plus. Yeah. Now, does anyone know what this -3 does? The graph is just a little different than this, so you're right. The -3 actually moves it 3 to the right. So the official graph then of this guy is actually 1, 2, 3. Even though it's minus, it actually moves it to the right. It's kind of weird, but if we played around and put some numbers in, we could figure it out. Does anyone want to guess if this was x plus 3? It moves it 3 to the left. So it is opposite that side. All right, now how do we do domain? So that's the graph. Like I said, this one, it just happened to say graph on the homework, so I thought we would do it. What's the domain though? Underneath the radical for domain, underneath the radical must be greater than or equal to 0. That's a fancy way of saying it has to be positive. Underneath the radical has to be positive. So we add a 3 to both sides. So x has to be greater than or equal to 3, which kind of, do we see that on our graph? I know we kind of talked about, you know, but that actually kind of makes sense that I'm not going to have a graph until 3. Okay, how do we write that with interval notation? Does anyone want to try? Yeah, go ahead, John. That's what I was going to write too, but it's greater than 3. So the very first thing I have a graph is at 3. So, and 3 is okay. 3 is going to give me a 0. 0 underneath is okay. And then to infinity. Beautiful. Good. Very good. Yeah, that was a little bit different. Maybe it's kind of nice that they had us graph. Can you visually see that now too? 3 to infinity, I have a graph. That's kind of what the domain is saying too, like where at least the x values where I'm going to have a picture. Say that again? Yeah, yeah, that's true too, yeah. All right, who wants a hard one? 8. F of x, we'll go back to f of x. Square root of 4 minus x, and then minus the square root of 1 plus x. All right, so we just have to do each one separately. This one, and then tie them back in together. Because overall, we do have to tie them back in together because both of them together makes up my one function. But let's start. Individually, 4 minus x has to be greater than or equal to 0. And not union, but actually intersection. And at the same time, we have to make sure it doesn't make this 0 either, or doesn't make that negative. This can't be negative either. So 1 plus x has to be greater than or equal to 0 also at the same time. Are you okay? So for that, now that's a good question. When he said, how do I know intersection or union? Every time, even when I finish this, well, this one's going to be a little bit different, but if I'm stating the domain, it's always going to be union. Okay. If I'm stating the domain, it's always going to be union. This one just happens to be intersection because I want these two things happening at the same time. Okay. Let's think about this too. This says I can pick something. Union is the word or. So it's okay if I pick 0, or it's okay if I pick, we can put an or here, I could pick 7, right? It's either one. I can't pick them at the same time. So it's one or the other. That's when it's union. But here, it has to make this positive, and at the same time, this one has to be positive as well, right? It's not going to make a whole lot of sense if it's okay here, but not okay here, because overall, it's one problem. Right? So this is kind of a special case. This is probably the only time that we're going to see this and. Right? Yeah, that's a good question. Let's bring that down. So it's got to fit this and this at the same time. Okay. Let's take a look at the answer too, because I think that might help too. So this, what do we want to do here? Probably to make it easier, add the x. Did anyone subtract the 4? If we subtract, let's do the worst case scenario, because if we subtract the 4, we have to do a little bit of work. It might actually be okay though. Bring down, make sure you don't lose that negative. What else do you have to do? When you divide by a negative, you have to switch that side. All right, this one's probably good to go. We're just going to subtract the 1. Okay, so let's take a look. What is this saying? Numbers have to be less than 4, equal to, but let's just do in general. Numbers have to be less than 4, and at the same time, so that it works both, numbers have to be greater than -1. So bigger than -1, but less than 4. That's totally doable, right? What's a number bigger than -1 and at the same time less than 4? 0, yeah, right? Yeah, I mean, that's just the easiest one to think of. So there are numbers that are bigger than -1 and less than 4. Now, how do we write that finally? We find one that's nice to write in interval notation. Bracket, because it's equal to. We're going to go from -1 and we're going to stop at 4. Yeah, that's the way to say between -1 and 4. How come brackets? Because it is equal to. How come equal to? Equal to will make at least one of them 0, and that's okay. The square root of 0 is fine. You just don't want the negatives. All right, so that one was a little bit harder. That one, I will tell you, that's the only time that you'll use that intersection. How about, okay, let's do, if we can get through 2 more, that'd be perfect. Let's just talk about this one. This one looks intimidating, but it's not too bad. F of x equals 3 minus 0.2x. What is that? Say that again? Oh, okay, like this here. Beautiful, yes, yeah. This, okay, so this is f of x, nice. This is 3, and this is 0.2, which we would read as 2/10. Goes back to 6th grade, 2/10. You can actually write that as 2/10. Not tenths, but tenths. We're not sleeping out, we're not camping. And then that reduces to 1/5, yeah. Now, she said, she made it even fancier. She said you could even do it as x over 5. Yeah, good, very good, that's awesome. Yeah, make sure. We might want to leave it at like this though. What would happen if I take this and rewrite it as -1/5 x plus 3? What is that? You have yourself a line. Yeah, so not only is it a polynomial, it's like the most basic polynomial, it's a line. Now, I probably should have said, we could have actually, if you see up here that this is a polynomial, what's the domain? -∞ to +∞. But I'm glad we rewrote it because this happens to be one on the homework where they asked us to graph it as well. So that, otherwise I probably would have backed us up and said, hey, that's a polynomial. You better write that domain. Domain is -∞ to +∞. Don't let even that decimal try to hide it. It's still a polynomial, -∞ to +∞. All right, how would we graph this though? Since this is one that we had to graph. I think, can we see that? All right, so we start at, we did this once, right? Where do we start? Does anyone remember? Start at the y-intercept, so we're going to go to the y-axis, and which number's the y-intercept? The 3. So 1, 2, 3, and then slope, because it's negative, we're going to go down 1 to the right 5. Down 1 to the right 5. Down 1 to the right 5, and if I did it again, I would go down 1 to the right 5. I know with the inequality, we had some trouble. This one is just, can you pick the graph? They graph four lines, and then you have to pick it. They may grab a parabola too or something just to throw you off. All right, let's do, we're out of time. So I want to get you guys out. So the last problem, we'll start, I'll put it on the board tomorrow. So you want to do WebAssign. But if you can't do the last one, we'll pick up there tomorrow. Okay, we'll be okay. And then where's my P through Z's? You're gonna go virtual. All right, we'll try it. If a few of you, if you want to come in, you can, because that room holds up to 25, so that's okay. If we have overflow, then we'll have to figure something out. Okay. Is anyone crying over virtual, or we're surviving the one day? For the most part, okay. Come and see me if you're not, because I want to make sure that you feel comfortable. Okay. All right, guys, have a great day. So do WebAssign except for maybe the last problem, okay? WebAssign except for the last problem.